Here's our first video on electrochemistry, and basically it's the study of electrons moving within chemical reactions. So first off is a very simple reaction. So we're going to start by looking at the definition of what a redox reaction is, and then we're going to go into another couple of new concepts, mainly oxidation numbers. So if we look at this reaction, we've got solid zinc and aqueous copper 2 sulfate. So here's my solid zinc, and I've got copper 2 sulfate, and it reacts to make zinc sulfate and solid copper. If I were to write my total ionic equation, just like what you guys did in grade 11, it looks something like this. So I've got solid zinc plus copper sulfate that's aqueous, so it actually splits up into its ions. And that becomes zinc 2 plus, plus SO4 2 minus, that's aqueous, plus Cu, that's solid. Okay, so that's my total ionic equation. If I cancel out the ions that are the same on both sides of the equation, my net ionic equation ends up being Zn, that's solid, plus Cu 2 plus, that's aqueous, becomes Zn2 plus, that's aqueous, and solid copper. So that's what I end up with. That's my total ionic, my net ionic equation. So if you look at this, basically what's happening here, so for zinc to go from solid zinc to zinc with a 2 plus charge, what had to happen here is zinc actually had to lose, or it lost 2 electrons. For copper to go from copper 2 plus to solid copper, copper actually had to gain 2 electrons. So what's happening in this reaction is basically reactions are getting transferred from the zinc to the copper to make the reaction go. And that's what a redox reaction is. It's really just examining any reaction where we have a transfer of electrons. So here are your definitions of reduction and oxidation. So reduction is a process in which chemical entities gain electrons, which is weird because you would think reduction should talk about losing things, but it's actually gaining electrons. The reason why we call it reduction is because it's losing charge, or when it gains electrons, you're gaining negative charge, so your charge reduces or your charge decreases. Okay, so that's what happens when you gain electron. So in the reaction that I had over on the other sheet, I don't think you can see that very well. In that reaction, basically what you get is Cu2 plus becoming Cu, and like we said before, that's a gain of 2 electrons, so that means that copper 2 plus was actually reduced. Oxidation is the opposite of that. It's a process in which chemical entities lose electrons. Okay, so in the above reaction, or the reaction that we just did in your notes, our zinc became zinc 2 plus, and in order to do that, it had to lose 2 electrons. So that's what an oxidation reaction is. So redox reaction, like I've said before, is a reaction where one reactant is oxidized and the other reactant gets reduced. So a quick couple of mnemonics to help you remember what the difference between reduction and oxidation is. The first one is Leo the lion says grr. So if you remember that, it's silly, but it works because Leo stands for loss of electrons, means oxidation. Grr stands for the gain of electrons, is reduction. So that helps you to understand that oxidation is loss and reduction is gain of electrons. Another useful mnemonic, if you don't like Leo the lion, you can use oil rig. So oil rig means oxidation is loss and reduction is gain of electrons. So whatever you'd like to use, whatever makes the most sense to you, please use that to make sure you're not mixing up oxidation and reduction. So let's do some work here, and let's try to identify what reactant is getting oxidized and what reactant is getting reduced. So if you want to pause the video for a quick second and try these on your own, feel free to do so, and I'm going to do the answers right now. So in this case, calcium goes from solid calcium to calcium 2 plus. In order to do that, it has to lose 2 electrons. So that means it is oxidation is loss. This is oxidation. Okay. Tin, on the other hand, went from 2 plus to something with no charge, which means it gained 2 electrons. Okay, and we know from oil rig, RIG, reduction is gain, so the gaining of electrons here is reduction. So calcium was oxidized and tin 2+ was reduced. Let's do the second example, same idea. So aluminum went from solid aluminum over to aluminum with a 3+ charge. So in order to do that, it had to lose 3 electrons. Okay, so that means if it's losing electrons, it's oxidation. Oxygen, on the other hand, went from something with no charge to something with a 2- charge. Therefore, it had to gain some electrons, and it had to gain 2 electrons to do that. And anything when you're gaining electrons is reduction. So there's the answer to those 2 questions there. All right, what about covalent compounds? Covalent compounds are trickier because they don't have charges, so it's tricky to figure out where these electrons are moving, but that doesn't mean that electrons aren't moving in covalent compounds. In fact, here's a perfect example of a reaction. It's a combustion reaction, and this reaction also involves the transfer of electrons. So to identify where the electrons are being transferred and where they're moving to, what's getting oxidized, what's getting reduced, we get these fancy terms called oxidation numbers, okay? And they are assigned to each atom and ion within a reaction. So in order to do that, you've got to learn a set of rules. Here are your 7 rules for assigning oxidation numbers. So I'm sure you can read. I'll go through each one individually and talk about some examples, and then that's the end of this video. So the oxidation number of an atom in an uncombined element, or an element that is all by itself, is always 0. So the phosphorus in P4 has an oxidation number of 0, same as O2 would have an oxidation number of 0 as well. Okay, so anything that's in an element all by itself has an oxidation number of 0. The oxidation number of a simple ion, number 2, is the charge on the ion. So Ca2+ has an oxidation number of +2. That's pretty easy as well. Numbers 3 and 4 are sort of exceptions, I guess you could say, and they're the sort of ones you've really got to remember. So the oxidation number on hydrogen is always +1. The only exception to that is in a metal hydride. So when hydrogen bonds to a metal, it ends up with a -1 charge. Okay, so for example, sodium hydride. Oh, this example is terrible. So in sodium hydride, ignore this, and I'll give you another one. In sodium hydride, in this case, hydrogen has to have a negative charge to balance it with a positive sodium ion. So your oxidation number on hydrogen in this case would be -1. That's what I was trying to put there. Over here, so an example where oxygen would have an oxidation number of +1 is something like H2O. Okay, so if hydrogen is not bonded to a metal, it always has an oxidation number of +1, and that's usually what you see. All right, rule number 4, the oxidation number of oxygen is 99% of the time -2. The only exception is if you have a peroxide, such as hydrogen peroxide, and in that case, oxygen is going to have an oxidation number of -1 instead of -2. The oxidation numbers of group 1 element ions is always +1. The oxidation number of group 2 element ions is +2. So again, that kind of relates back to these simple ions in question, or in rule number 2. Rule number 6, the sum of oxidation numbers in a compound must always equal 0 if you have a neutral compound. If you don't have a neutral compound, that means you have an ion, and therefore your oxidations must equal the charge on the ion. So that's pretty much the end of our video. You have this handout either right now with you, or I will give it to you in class the next time I see you. So if you want, we can do I'll do a couple of examples, but then it's your responsibility to do the rest and check your answers with me if you'd like. So, for example, if we want to find the oxidation number on nitrogen in NH3, I've got 1 nitrogen and I've got 3 hydrogens, and the compound has no charge, so overall my oxidation numbers have to add up to 0. So in this case, my hydrogen is going to have the positive 1 charge on it. So I've got 1 nitrogen plus 3 positive charges equals 0. So therefore my oxidation number on nitrogen is -3. So that's what I would write over here. So you can use a little bit of algebra to figure this out if you'd like. And don't be afraid if you get a fraction or a decimal place. Usually we write oxidation numbers as fraction. And that is it. If you want some extra work, there's a video I showed in class. So if you want some extra work, you can read through your textbook questions and do those as well.